In this video, we'll talk about creating linear equations in point-slope form. So let's talk really quick about what point-slope form looks like. So point-slope is another way of representing linear equations. And instead of doing slope-intercept form where we have y equals mx plus b, where m represents the slope and b represents the y-intercept, what we're looking at is y minus y1 is equal to m times x minus x1. Now it's worth noting here, m is still our slope, or our rate of change, whatever term you prefer on it. And the idea is x1, y1, that just means that's an ordered pair. x1, y1 is a point on our line. Hence the name point slope. So the idea is once I have a point and a slope, I can actually create the equation. Now it's worth noting we have to be very careful with these negatives here. So just be cautious. If I have 3 as my y coordinate, it's going to be y minus 3. And vice versa. If it's negative, it'll technically be y plus 3. So just food for thought for when we walk through the examples. So let's put this into practice here. If we're given the equation of a line, or we want to know the equation of a line, with a slope of 4 that passes through the point negative 1, 2. And actually, we don't have to do any math here. We've got everything that we need. We have the slope of 4, that's m, and this 1 here, the negative 1, is x1, and the 2 here is y1. So I can say y minus y2, which is 2 in this case, equals 4 times x minus x1, which in this case is a negative 1. Now I could simplify it a little bit to be y minus 2 equals 4 times x plus 1, but both of these are accurate equations for the line. And my job is done here. So sometimes point slope can be beneficial in that it can save you some work, but you do have to remember the formula for it, which is the drawback. Now let's take a look at another example. Let's say all I know is the line passes through the points negative 1, 8 and 5, 12. So the idea is basically I just need to get the slope. And we have many, many ways of doing so. So I'm just going to go ahead and do it one way. You can use the formula, you can draw it out, or you can do it kind of the way that I like to do it, which is where I just think about, okay, how do I get from negative 1 to 5? Well, I have to add 6. That's my change in x. And my change in y, how do I get from 8 to 12? Well, that's plus 4, which means that m, which is equal to change in y over change in x, is going to equal positive 4 divided by a positive 6, which is 2/3. Now that's a fraction, but that's okay. So what we can do now is we can choose basically which point we want to use. It doesn't really matter which. We can say, okay, let's let x1 be negative 1 and y1 be 8. So then we could say y minus y1, which is 8, equals 2/3 times x minus x1, which is negative 1. Or we could use the other point, since we're given 2. It doesn't matter which. They both work out to be the same. If we were to reduce them, they would be equivalent. So we could say y minus 12 is equal to 2/3 times x minus 5. Either one of these is totally fine. So there's point slope. There's a quick application. The idea is you find slope, and then if you have a point, or if you have a graph of an equation, you can just pick any point you want, and you can make your equation. It's a pretty effective way of making equations for lines. It might not be the best for graphing, but it does make the equation, and that is ultimately the goal for a lot of these questions. So, food for thought, and basically it's a trade-off. Do you want to remember multiple formulas, or do you want to do more work? That's usually the choice between slope-intercept and point-slope form.